All right, so first thing I want to say about particle motion is it's not a particle like a dust speck. You need to get that out of your head first of all right away, because if you think of it as like a tiny little particle, like Horton Hears a Who or something, like a particle is just anything with motion. So your particle could be a car or a plane or a train or an elephant. Do you understand what I'm saying? The particle is just the thing that has motion. I don't know who decided that that's the word we were going to use. We should probably just call it motion notes, notes about motion, but your particle is just the thing that's moving. All right, position is written S of t, and that is just where the particle is. So an example of units for that would be feet. It could be meters or miles or whatever have you, but just as an example, it would just be where it is. So just feet. Velocity is v of t, and that is the first derivative. So it's the derivative of position. That should make sense. It's a rate of change. All right, so derivative means rate of change. So let's write that down. Rate of change of the particle. So those units aren't going to just be feet. Now that it's a rate of change, like an example, bless you, would be like feet per second. And I just always say it has to be something per something else. So like miles per hour. And velocity is directional. So if velocity is positive, that means that your particle is moving in the positive direction. And so that could mean, it depends on the context of the question, but it could mean forwards or upwards or to the right or away from home or whatever it is. Remember that Alice went for a walk? She walked away from home, had positive velocity, walked back home, had negative velocity. So velocity is directional. If velocity is negative, that means you're moving in the negative direction. And so again, that could be downwards or to the left. Does that make sense? I call this the physics unit when we do this. And then if the velocity equals 0, we call that at rest, which means no motion. It means you're not moving, you are staying still. Good so far? Okay. Acceleration is a of t. It's the derivative of velocity, which is the second derivative of position. That means it's a rate of change. Like the dream within a dream. So it tells you how the velocity is changing. So is the velocity going up or is the velocity going down? So what would be an example of units for that? If you have a rate of change, it would be feet per second squared. It's feet per second. So the shorter way to write it is feet per second squared. So for acceleration, if acceleration is positive, it means you're being pulled in the positive direction. This is the thing that gets everybody. It doesn't mean you're moving in the positive direction. It means you're being pulled in the positive direction. You could be moving in the negative direction and be getting pulled in the positive direction. The acceleration is the pull. All right, so if acceleration is negative, it means you're being pulled in the negative direction. And if your acceleration equals 0, that means you have a constant velocity, which doesn't mean you're at rest. It doesn't mean you're not moving. You are moving. It's like cruise control. Does that make sense? Like you're moving at a constant velocity. So that's like setting your cruise control. If you want to even write cruise control next to that, like that's what acceleration being 0 is. All right, speed and velocity are related. But speed is not directional. Like your speedometer in your car does not go negative. Even if you're in reverse, it tells you that you're going positive miles per hour. Does that make sense? So speed is the absolute value of velocity. So speed is always going to be positive. And here is the question that they are like guaranteed to ask you on the AP exam. And everybody always like stumbles over it. It's really simple, right? They will ask you if you are speeding up, if your particle is speeding up or slowing down. Speeding up means your velocity and acceleration are the same sign. They could both be positive. Here's an example. You're going forwards in your car, that's positive velocity, and you're pressing on the accelerator, that's positive acceleration. You would be speeding up in the positive direction. But they could both be negative. This is like if you're skydiving and you jump out of an airplane before you've pulled the parachute, pull the parachute, okay? But like before you've pulled it, you're going down, so that's negative velocity, and gravity is pulling you down, so you have negative acceleration. You are speeding up in the negative direction, not good. So make sure you have a parachute. But they could both be negative, right? And then slowing down means that velocity and acceleration are opposite signs. The example I always use about that is pretend you're driving in your car down 360. You are moving forwards. That means you have positive velocity. When you hit your brakes, you see a red light. When you hit your brakes, do you immediately start going backwards? No, that would be some insane whiplash, okay? When you're going forwards, you have positive velocity. When you hit the brakes, you still have positive velocity. You're still moving forward. You have negative acceleration. So you're moving forward, but being pulled backwards, and that is what causes you to slow down. If you like the parachute example, when you jump out of the airplane, you still have negative velocity because you're still moving down, but the parachute's pulling you up. So you're slowing down. It's when they're at odds with each other. Does this make sense? Some of you are like glazed over. I know it's the end of the day. All right, let's try a few problems with it. That's essentially the whole lesson right there. We're just going to do a few problems. Suppose a particle, that just means anything with motion. You could pretend it's a dog or a cat or a person, a car, or whatever, is moving along the line with its position given by this. Make sure you're aware of what you're given because they could give you position, velocity, or acceleration. So this is position. We have seconds and we have feet. So make sure you're aware of the units. Find the velocity and acceleration functions. All right, that just means to take the derivatives. So that's an easy question. Velocity would be what? Yep, perfect. 3t squared minus 3. And then acceleration would be the derivative of that. That would be 6t. Letter B, when is the particle at rest? Is that when velocity is 0 or acceleration is 0? Velocity is 0. So we're going to set this velocity function equal to 0 and solve it. So you would add 3, divide by 3, and then square root. Now, when you square root, you get plus and minus, but we don't do negative time. So it would just be time 1 second. When you're doing problems like these, it's always assumed that your item, your particle or whatever, is moving along a line, a straight line. I don't like saying straight lines because that's redundant. All lines are straight, okay? But moving along a straight line. The particle can't turn around without stopping. In order to turn around, you must stop. Okay, I know it's not like that in real life, like in your car, you can turn without stopping, but we're saying that everything is moving along a line, so you cannot turn around without stopping. All right, so we're gonna fill in this chart just to be super thorough and know what's going on here. Let's plug into position, 0, 1, and 2. I gave us little numbers, right? If you plug 0 into position, you get 2. If you plug 1 into position, let's see, 1 minus 3 is negative 2 plus 2 is 0. And if you plug 2 into position, let's see, that'll be 8 minus 6 is 2 plus 2 is 4. All right, now we're going to plug 0, 1, and 2 into velocity. That's this right here. If you plug in 0, what do you get? Negative 3. If you plug in 1, 0, we just found that. That's when it's at rest. And if you plug in 2, what is that? 9. Cool. And then acceleration is right here, 6t. So 0 is going to give you 0, and then 6, and then 12. So for part D, we're going to draw a number line indicating where the particle is at times 0, 1, and 2. So here's my number line. Again, it's going to move along a line. Looking at your positions here, I'm going to need my number line to go from 0 to 4. Like these are all the positions that I need. Now I'm going to draw a circle for my particle. You can draw whatever you want. You can draw a heart or a star or a little car or a bird. Remember, it's anything that has motion. So I don't want you to get hung up on the word particle. So where did the particle start? 2 feet, wherever that is, 2 feet from home, I suppose. Maybe it's an ant that's 2 feet from home. I don't know, pretend it's whatever you want. Then it moves to 0. So it goes this way. So it moved to the left. Do you see how it had negative velocity? Velocity was negative here. That's because it was moving to the left. All right, then it moves to 4. So it has positive velocity. See how it had negative velocity changed to positive velocity? That's because it went left and then it went right. Actually, let me just go ahead and jump down here and answer question F real quick, because we're just going to look at the number line. What is the total distance traveled by the particle in the first 2 seconds? All right, well, it went from 2 to 0, that's 2 feet, plus what? 4. From 0 to 4 would be 4 feet, so a total of 6 feet. Now, I'm going to bring this up because I'm sure like one of them is thinking this, because do you guys remember total distance from an integral standpoint? Do you remember integral total distance in the first 2 seconds, and it was absolute value of velocity? Do you guys remember this? Okay, because when I taught this last year, everybody was all up in arms. Well, why can't we just do this? If you do this, you will get the same answer. Well, Ms. Cole, why do we have to draw these number lines and do this? What if you don't have a calculator? That's my argument for that. How would you do this without a calculator? Do you remember you typed them in? So like, that's my, like, because everyone was really upset that I was having them draw a number line. I was like, number one, it's not a big deal. And number two, what if you don't have a calculator? So like, thank you for not giving me a hard time about it. But this will give you the same answer as that. So when we get there in a couple of units, it's the same thing. Okay. And then I just had us write a description just because I think it's important for you to understand like foundationally what's going on. So the particle moves from 2 feet to 0 feet, and it is slowing down. How do I know it's slowing down? Well, look at the table we made. In between 0 and 1, your velocities would be in between -3 and 0. That means they would be negative. If you want to even like put a little negative sign, you can. For acceleration, your values would be between 0 and 6, which means they would be positive. If they're opposite signs, that means slowing down. And then what does it do once it gets to 0? But what does it do before that? If velocity is 0, it stops. Before it does any of the rest of that, it stops. So it stops at 0 feet. And then you guys are right, it moves to the right. So it moves from 0 feet to 4 feet. And whoever said speeding up, you are correct. It's hard for me to tell who's talking with the masks on. Speeding up. The way we know it's speeding up is if you look at this table, your velocities would be between 0 and 9, that's positive. And your acceleration would be between 6 and 12. Those values are also positive. So it's moving to the right and it's speeding up. All right, so again, be careful about what they give you. First of all, this one's given as a graph instead of a function. And also it's the graph of what? Velocity. So just be careful with what they give you. Most of the time they would give you position or velocity. Rarely, but I've seen it happen. They'll give you acceleration, but just be careful with what you've got. So, and there's no units for this. We don't have to worry about it. At what time is the speed the greatest? Speed is the absolute value of velocity. So kind of pretend all these values are positive. Which one is the greatest? Like, or where would you have the greatest value? T equals 8. Do you guys see that right here? I know it's like the most negative, But if you were absolutely valuing that, it would be the most positive. So at time 8, and it's not seconds or anything like that. They just didn't give units. All right, letter B, this is kind of multiple choice. At times 2, 6, or 9, is the acceleration greatest? Explain your answer. Let's just find the acceleration at each of those times. So acceleration at 2, acceleration at 6, acceleration at 9. And we'll just see which one's the biggest. So you're looking at velocity. Acceleration is the derivative of that. So what does derivative mean? Derivative means what? Slope. Look at the tangent line. Perfect. Okay. So we're going to just look at the slope at each of those points. All right. So here's 2. If I draw in a tangent line, what's the slope? 0. All right. So that's 0. 6 is right here. Now, I mean, this is linear, so it's just what's the slope of that line? It looks like -3/2, -3/2, -1.5. And then at 9, it's right here. Again, that's linear, so it's just what is the slope of that line? Up 3/1, so 3. So when is the acceleration the greatest? Acceleration is greatest at time 9. It said justify, but you don't really need to write a statement because we showed all 3 of the answers. What would your reason be? Because that's the largest one. You know, like this is, do you guys remember candidates test? We haven't gotten there yet, but we will soon. Candidates test, and you make that chart, you don't have to write a justification because the chart is your justification. We'll get there. Anyway, this is your justification because you showed every single one of them. All right, over what time intervals is the particle moving to the left? That means velocity would be negative. You're looking at velocity, so that's below sea level. I call this below sea level. All right, so where is the velocity below sea level or negative? Yeah, from 4 to 10, because velocity is negative there. I say that so much though that I had somebody one year write above sea level or below sea level on a test. Don't write it on a test, okay? Positive and negative. All right, over what time intervals is the speed of the particle decreasing? You have to look at both velocity and acceleration. So what I usually do is make a number line with velocity and acceleration on it. We want to go from 0 to 11. And on your number line, you can put every single number if you want, but you need all of the zeros and anytime the graph changes direction. So what are other values that we're going to need on here? We need any zeros or when it turns around. So 2, what else? 4, 8, and then one more, 10. So I'm going to put velocity on the top, acceleration on the bottom. This is velocity. So where it's positive and negative is just above and below sea level. All right, so velocity is positive from 0 to 4. And then velocity is negative from 4 to 10, and then positive from 10 to 11. So that's just the graph you're looking at. Acceleration is the derivative of that. Now you're not looking at whether it's above or below. Now you're looking at increasing versus decreasing. It's the slope. So acceleration is positive from 0 to 2, negative from 2 all the way to where? Yeah, good. We're decreasing. So negative all the way from 2 to 8, and then positive from 8 to 11. And so we're looking for where these are opposite signs. Speed decreasing, that means slowing down. So opposite signs would be here and here, and that's it. So from 2 to 4 and from 8 to 10, because velocity and acceleration are opposite signs there. A common mistake I get on this is that people will say because they are opposite, they will not give you credit for that on the AP exam. It has to be opposite signs. Opposite would be like 7 and -7. Do you get what I'm saying? Like it's more specific, but you have to say opposite signs to get credit for that. Now, some people don't like doing that and they'll do this instead. And it is less work, but my brain doesn't really do it this way. But if yours does, this is cool. For this section, we're above sea level and it's increasing. That means the same sign. It's like when they do the opposite thing though. So see, like from 2 to 4, you're above sea level, so velocity is positive, but decreasing, so acceleration is negative. You can do it that way, like just kind of look at it without having to make this number line. But I think this is a little bit more concrete. That's why I do it. This is like easier for me to see. But if you want to get the answer without drawing that, it's not a necessary thing. All right, this is the one we're going to need the calculator for. The rate of change in kilometers per hour. So that's, what did they give us? Position, velocity, or acceleration? Good, rate of change, or you could see something per something else. They gave us velocity of a hot air balloon is given by this times 0 to 4 in hours. Assume the balloon is initially, that means to start out with, where? Okay, it has to be on the ground or you cannot get in. All right, so let's go ahead and type this function into y equals and take a look at it. So if you could go to y equals, type that in. I know it says t, but we're going to use x. So put that into y equals, don't hit graph. You want to make sure that your window matches what they gave us. So go to window, which is right here. It's your second menu button. What time interval did they give us? 0 to 4. So you want to make the x's be 0 to 4. The y's you can just play with. I would just leave it negative 10 to 10. We'll see what happens. We can always adjust it and then hit graph. But if they give you a window, which they usually do, you want to change that. And here's the first thing I always get. It's cool. The balloon starts out up in the air. No, it doesn't. Where did we just say the balloon starts? You're not looking at position. Thank you. You're looking at velocity. So this velocity is above sea level. That means that the balloon moves up. That should make sense because if it starts on the ground, it really can't go anywhere except up. The hot air balloon is not going to burrow into the ground like a gopher, okay? It goes up. And then for this portion, the velocity is below sea level. That means negative. That means the balloon goes down. And then this portion, it goes up again. So here's my question. Do you want to get out of the balloon at the end of these 4 hours? No, why not? You're up in the air. Because everyone's always like, yeah, I want to get out. It's been 4 hours. I'm like, yeah, but you better have like a parachute or something because it's up in the air. Right, so that's what's going on. Letter A, for what values is the altitude of the balloon decreasing? Well, that would be this portion right here. That's where the velocity is negative. So from this point until this point. Now you have to make your calculator give you those values. So how do I calculate this value right here? Do you guys remember what buttons to press? A lot of buttons. Good, second trace, which says calculate, and you want to calculate a 0. So choice number 2. Now you can move around the cursor for this. I like to just do it manually because I think that's easier. This 0 is between 1 and 2. So when it says left bound, hit 1, enter. Right bound, hit 2, enter. And then for guess, hit 1.5, enter, or anything between 1 and 2. And then you don't have to worry about the arrows and where the cursor is. You can just type it in manually. All right, so there we go, 1.571. Yeah, you can round if you want, but I like to truncate. So from 1.571 until, now we're going to do the same thing, calculate the other one. Second trace, 0. Now that one looks like it's in between what? 3 and 4. So left bound, 3, enter. Right bound, 4, enter. Guess, 3.5, enter. 3.514. Did it say justify? It didn't, but you know what? I'm going to do it anyway. From then to then, because velocity is negative there. You never know when they're going to ask you to justify, so I always like to throw that in. All right, find the value of r prime of 2 and explain what it means, indicate units. All right, so first let's find r prime. So what is our derivative going to be? You have to look back at the function in the little paragraph at the beginning. Minus 8t. Perfect. And we're going to plug in 2. So 2 squared is 4 times 3 is 12 minus 16. So negative 4. Now r of t was a velocity. So what did we just find? Acceleration. So your units are going to be, what was it, kilometers? Kilometers per hour, kilometers per hour squared. And this tells you whether the velocity was increasing or decreasing. Since it's negative, it means the rate was, if it's negative, it means the rate was decreasing. Okay, so the rate is decreasing 4 kilometers per hour squared at time, what did we plug in, 2? Hey, but Ms. Cole, you wrote a +4 there. That's okay because I said decreasing. Do you get that if you said decreasing negative amount, that's like a double? Like, no one's ever asked me that before. Probably just don't do that. Increasing at a negative amount, don't do that. That's like giving directions to someone and saying, hang a straight up here. Like, just don't do that. So the rate is decreasing 4 kilometers per hour squared at time 2 hours. I don't know how to tell you this, but they usually make the justifying worth a point. And if you don't put the at time 2 hours, they just won't give you that point. They won't give you a half a point. They will just give you nothing. All right, when is the balloon closest to the ground? Oh, mine went to sleep. When is the balloon closest to the ground? It's closest to the ground when it's finished moving downwards. Okay, so it moves up for all of this, and then it moves down for all of this. So at this time right here is when it's closest to the ground. Does that make sense? The other way you can think of it is it's a change from negative to positive. So that's where it's going to be closest to the ground. So it was, we already found it. What was it? 3.5 something, 3.514 hours. And then when is it at its maximum altitude? Well, when it's finished moving up. So it moves up for all of this time. And right here is when it starts moving downward. It's a change from positive to negative. So what was that? It was 1 point something, wasn't it? Time point 1.571 hours. And what I usually get about this one is people are like, well, wasn't the balloon closest to the ground when it was on the ground? Correct, except look. It says between 2 and 4. It was on the ground at time 0. So that's why that's not the answer. All right, so in the table below, we're given values for velocity and acceleration. It says both velocity and acceleration are differentiable. This is going to come up in this very first part that we're going to do. So hold on to that. It says that they're differentiable functions of time. Velocity is decreasing all the time. Use the data to answer the question. Letter A, is there a time when the particle's at rest? All right, let's review what at rest means. I'm just going to write it off to the side. At rest means what? 0 for what? Good, okay. Velocity is 0. So you're not looking at the acceleration values, just velocity. So look through the velocities. I'm just looking for a yes or no. We'll justify it together. But yes or no, is there going to be a time when the velocity equals 0? Yes is the correct answer. In between what 2 times? Look at the times. In between what 2 times will we get velocity to be 0? Between 2 and 6. You must bring up that the function is continuous though, because that's how you know it's going to have to go through 0. If you have a positive and a negative, it's going to have to go through 0, but only if it's continuous. How do we know that it's continuous? This is differentiable. So it's wordy, but you have to write that. We're going to say, well, yes, first of all, since velocity is differentiable, and I'm good with you abbreviating, it is also continuous. So you have to say that. Since velocity is differentiable, it is also continuous. And now you can be as wordy as you like here, and you can write it out in words. I'm going to do it with math symbols because it's a little shorter. All you need to do is say that 0 is between these 2 values. So I'm going to say v of 6 is smaller than 0, which is smaller than v of 2. Velocity at 6 was negative. Velocity at 2 was positive, so 0's got to be in between. Your little alligators eat left to right. Remember, alligator wants to eat the bigger number. Remember, such simpler times. All right, so since all of that is true, there is a time when velocity equals 0. Are we all good? But you have to mention that the function's continuous and that 0 is in between. All right, and then B, at what time indicated in the table is the speed decreasing? That means velocity and acceleration are what? Opposite, different signs, opposite signs. Okay, so let's see. At what time, and you've got choices, 0, 2, 6, or 10, are velocity and acceleration opposite signs? At 2. I get this all the time. 0 doesn't count because 0 isn't positive or negative. So it would just be time 2 because velocity at 2 and acceleration at 2 are opposite signs. All right, and then last one. Cars traveling on a straight road. Again, all of this particle motion involves a straight line. For times 0 to 24 seconds, velocity in meters per second is modeled here. So they gave us velocity, just be aware of what you were given. And then they throw piecewise linear. Linear means line, piecewise means broken into pieces. I almost wish they wouldn't even say it because like, no kidding. Do you see how these are lines and it's broken into pieces? Like, but then that throws everybody off. Anyway, it like looks like a trapezoid here. Anyway, that's the graph of velocity. For each of v prime of 4, v prime of 20, find it or explain why it doesn't exist, include units. All right, that's the derivative of what we're looking at. So at 4, which is right here, can I get a derivative at that point? No, why not? Sharp point. Okay, sharp edge. So v prime of 4 does not exist due to sharp edge. And then v prime of 20, let's see, here's 20. We can get the slope at that point. It's the slope of this line. So let's see, we went down 20 and over, what, from 16 to 24 would be 8. So down 20 over 8, negative 28. Or we could reduce that. What would that be? Negative 5 halves. And they said to put units if you could get an answer. Velocity was meters per second. So this will be meters per second squared. Good. It is an acceleration. And then letter B, let A of t be acceleration. Write a piecewise function. Okay. Again, this always gets everybody because it's like piecewise is scary. All you have to do is put a swirly bracket. If you can't draw one of those, just draw a squiggle. I don't care. I'm not grading your art skills, all right? There's going to be 3 pieces. Why 3? Like, why would there be 3 pieces to this? Yeah, 3 different linear equations. All you have to do is put the slope for each one. So what's the slope of this section? Well, it went up 20 over 4, so 24ths, 5. And then you have to say from where to where. So from 0 to 4. I didn't include the 0 because you really can't, I mean, like, you get a derivative at that point. I mean, I guess it's arguable. It's safer to not put the equal though, because they won't mark it wrong. If you don't, like, what they said once is if it's supposed to be an equal to, but you put a not equal to, then they won't mark it. Oh, actually, we can't put an equal to here either because of the sharp edge. So we're just gonna make them all not equal to. All right, and then what's the slope for the next section? All right, 0, and that's from 4 until 16. And then we already found this last one, it was negative 5 halves from 16 to 24. And that's a really easy question, but it blows most people's minds because it's piecewise and they're just like checked out for there. So just like stay calm, it's not that bad. And then this last one says find the average rate of change. What does that mean? Slope, regular old algebra 1 slope from 8 to 20. So we need a point for 8 and a point for 20, and we're gonna slope them. So 8, what will be the y coordinate? 8, 20, and then 20, it's right here in the middle, so 10. And then all you have to do is the slope, 10 minus 20 over 20 minus 8. You don't have to simplify that down if you don't want to, but we are going to put units. This was meters per second. We did a slope of that. So meters per second squared.